All right, let's get into this. We're about to look at an AI that honestly feels like it's performing pure magic. It takes a few totally separate photos and turns them into one seamless video. It's a pretty wild ride into how a machine actually learned to reverse engineer reality itself. So just look at this. On the left, you've got a handful of choppy individual photos, but on the right, you get a perfectly smooth, totally continuous video. The AI didn't just, fill in the blanks. It looked at these separate moments and understood the scene so well that it could create everything that happened in between them. And that, right there, is the central mystery we're diving into. How on earth did an AI learn to see the moments that were never even caught on camera in the first place? Now, this amazing tech is called a NeRF, which stands for Neural Radiance Field. And it's incredible for things like training self-driving cars or even creating Hollywood-level special effects. It would be absolutely perfect if the older versions actually worked. But they didn't, because they had one very spooky problem. That's right, they were literally haunted by these ghostly floaters. They're these blurry artifacts that just kind of drift around, and they totally ruin the illusion. It turns what should be a masterpiece into this unusable, blurry nightmare. So, where did they come from? Well, to get where these ghosts come from, we need to solve a little mystery. Let's call it the Magic House Mystery. Okay, so picture this. You're hunting for a new house. You find a place that looks pretty good, so you decide you're going to drive by a couple of times on different days just to check it out. You pull up on Monday, and there it is. A nice, pleasant blue house. Looks great. You make a mental note, and you drive off. But then you come back the next day, on Tuesday, and the house is now fiery red. A completely different color. What is going on? So you're left asking yourself, is this some kind of magic house? Does it change color every day? Maybe that's why the asking price is so high. But of course not. The truth is way simpler. The house never changed at all. The real problem was that on Monday you were wearing blue sunglasses, and on Tuesday you were wearing red ones. And that right there is the sunglasses problem for this kind of AI. It would look at all these different photos, but each one was taken with slightly different camera settings, brightness, color balance. The AI thought the house was changing, when it was really just the camera's sunglasses that were different each time. And all that confusion is what created those ghostly floaters. But now, a master detective has finally shown up to crack this case. It's a brand new technique from NVIDIA called PPISP. It's a bit of a mouthful. It stands for Photorealistic Post-ISP. And here's the genius move. This new AI completely flips the script. Instead of getting confused by the changing house, this AI detective basically said, you know what? Forget the house. I'm going to analyze the sunglasses first. It decided to figure out the camera settings before looking at the scene. And the results of that simple change? Well, by focusing on the camera's distortions first, the AI could finally see the truth of the scene. The ghostly floaters are gone, just a crystal clear, perfectly stable image. Okay, so how does this master detective actually do it? How does it crack the case? Well, it follows this really clever process to basically solve for reality. It's a 4-step process that surgically removes all the camera's influence. First, it solves for exposure, so the overall brightness. Second, it nails the white balance. That's like taking off the colored sunglasses. Third, it actually learns the physical flaws of the camera lens itself. How the edges of a photo can get a little darker. And finally, it corrects for the strange ways a digital sensor can distort light. The whole thing is so incredible that one of the researchers just put it like this. It is like it reverse engineered the camera that took the picture. That is insane. It's not just cleaning up a photo, it's understanding the very tool that created the photo. I mean, stop and think about that for a second. To see the world clearly, this AI had to build a simulation of a digital camera's brain inside its own brain. It had to learn how a camera thinks just so it could see past all of its little tricks and deceptions. All right, so let's get to the detective's final report. We'll look at what this all means, and just as importantly, what even this master detective can't quite figure out. At least, not yet. And what's really fun is that there are these almost philosophical takeaways here. This AI is teaching us to separate the raw facts from the lens we're seeing them through. It reminds us that we have to acknowledge our own biases. Because really, the only way to see the world clearly is to first understand our own lens. Pretty deep for a bunch of code, right? But as amazing as this AI is, it's not foolproof. It has one major weakness, one sneaky trick that modern cameras pull that still trips it up. And that weakness is something called local tone mapping. This is a sneaky feature your smartphone camera uses all the time. It doesn't play by the rules. It'll brighten up just a person's face in a photo or darken just a bright window instead of applying one single rule to the entire picture. And that's the heart of the problem. Our AI detective expects the world to follow consistent global laws of physics. But a smartphone camera? It'll cheat. It'll break those physical laws just to make a picture look a little prettier. And when the AI sees these little local tricks, it gets confused because they just don't fit into its clean mathematical model of reality. So, we'll end with this thought. This entire explainer has really been about an AI learning how to tell the difference between objective reality and the distorted lens it was being viewed through, which really leaves us with a pretty fascinating question. If an AI can learn to see past a camera's bias, what biases could we learn to see past in ourselves?